Okay, Assalamualaikum and hi everyone. Kita akan masuk kepada 10.2 which is electron diffraction. So as we can see from the topic, it said here this is electron and we know electron is a particle, and here diffraction only happen kalau dia ada wave property. So kita nak buktikan adakah electron as a particle can have a wave properties. Okay, so we go to the first learning objective. Learning objective 10.2a describe the observation of electron diffraction in the recent German experiment. So as we can see in chapter 10.1 before this, I mentioned that electron as a particle can behave a wave properties. Okay, bila dibuktikan melalui the recent German experiment. Okay, so this is the setup for the recent German experiment. So the setup only consists of this tube, the green one tube, a cathode here, this is the cathode, the anode here, and a graphite films. So ada graphite films dekat sini. Okay, and this part here is the result at the screen expression pattern. So how this experiment happened, so I show you here at the explanation. So in 1927, two physicists, so we have two physicists, C.J. Davison and L.H. Germer. So that's why nama eksperimen ini ialah Davison-Germer experiment. They both carried out electron diffraction experiment to prove the de Broglie wavelength. So apa yang Broglie kata, lambda is equals to h/p. So lambda is the wave properties and p is the momentum, is the particle properties. So dia nak buktikan the electron as a particle can have a wave properties. Okay, so how this experiment is carried out? So a graphite film is used as a target. So di manakah graphite films? Here is my graphite films. Ini kita punya target. Okay, so this is our target dan bentuknya ialah crystal lattice. Crystal lattice shape. Okay, macam mana bentuk crystal lattice? Sekejap lagi saya tunjuk dekat kamu. Okay, so a beam of electron in cathode ray. So as we know, a cathode here, okay, cathode, dia bertindak as a emitter. Okay, dia emitter dan dia emit electron. Okay, so a beam of electron, maksudnya ada banyak elektron. Beam of electrons in a cathode ray tube is accelerated by applied voltage toward a graphite film. So cathode biasanya charge negatif. So here charge-nya negatif dan anode charge-nya positif. So kita punya setup ini kita sambungkan kepada power supply positif dan negatif. Okay, right. So cathode as a negative, dia fire electron. So where is our electron goes? So electron akan pergi ke anode sebab anode here bertindak as a collector. So anode bercharge positif dan dia bertindak as a collector, as we learn in chapter 9. Okay, so the electron yang keluar daripada cathode, dia akan accelerate towards the graphite film. So graphite films, macam mana elektron nak bergerak? Sebab ada positive plate dekat sini, so dia akan accelerate toward here, then dia akan hit our target which is graphite films. Okay, okay. The beam of electron is diffracted after passing through the graphite film. So sepatutnya kita nampak elektron ni ialah particle. Bila dia pass through, dia akan hit here. Hit elektron akan ada dot. Sebab elektron as a particle, kita rasa dia akan menghasilkan a dot pattern lah, maksudnya dot sebab elektron. Tetapi as we can see here, we saw this kind of pattern, which is this pattern, which is a diffraction pattern. Okay, sebab kita tahu diffraction pattern ini hanya terjadi kalau dia ialah wave, as we learn in chapter 8. Tetapi bila kita fire an electron as a particle, pass through the graphite films, we saw this kind of pattern. Which is pattern ini ialah kalau kita ada wave. So dia kata dekat sini, a diffraction pattern is observed on the fluorescent screen. This show that beam of fast moving particle, which is electron, behave as a wave. So dia berjaya membuktikan particle, which is electron, a particle do have a wave behavior. Sebab apa? Wave behavior? Sebab dia ada diffraction pattern. So we start with center bright, alternating dark and bright. Okay. So Davidson and Gemma discovered that if the velocity of electron is increased, so they increasekan velocity of this electron as the ring as seen become narrow. So kita punya corak ni makin rapat. Okay, the wavelength of electron decrease with the increasing velocity. Maksudnya sebab formula de Broglie ialah lambda equals to h over p equals to h over mv. So bila kita tahu kita increasekan velocity, what will happen to the lambda akan berkurang. So lambda ialah wavelength. Wavelength ialah jarak ini semakin rapat. Semakin laju, lambda semakin kurang. Maksudnya kita punya pattern semakin closer, semakin rapat. Okay, because of this equation, de Broglie equation. Sebab de Broglie kata lambda is equals to h over mv. So we know that lambda is inversely proportional with 1 over velocity. Okay, so the velocity of electron can be determined from accelerating voltage between anode and cathode. Sebab dia ada accelerating voltage dekat sini. So accelerating voltage maksudnya semakin tinggi voltage, semakin laju elektron bergerak. So kita boleh relatekan dengan conservation of energy. Initially ada potential energy, finally dia bergerak ada kinetic energy. So EV equals to half mv square. So kita tahu kita boleh kira velocity by rearrange this equation. So kita dapatlah velocity sama dengan Z to EV over m. So bila kita gantikan velocity ke dalam equation lambda equals to h over mv, so velocity yang ini kita gantikan dengan this equation, kita akan dapat lambda equals to h over Z to mev. So this is another de Broglie equation. Okay, so asalnya ini. Tapi kita just substitute sebab dia dah bergerak, dia dah ada velocity, kita substitute dengan equation V yang ini, kita akan dapat another equation lambda equals to h over Z mev. Okay, so kita tengok sikit macam mana eksperimen ini terjadi. Okay, so
particles at this, we'd expect them to go through the gaps and when they hit the atoms to not go through. So I suppose...
So this is the crystal lattice, which is kita punya graphite films. Dan graphite film kita sangat nipis. Dan dia kata kalau sepatutnya elektron pass through the ring ataupun the film, petak-petak ni, dia akan menghasilkan dot line je dekat kita punya screen. Tetapi apa yang terjadi, we saw this kind of pattern.
They're bright in the middle, then dark, then bright, then dark, going out both sides from the central dot. Okay. And this should remind...
Dia kata dekat sini, dia kata, this is our center bright, lepas tu ada alternating ring, dark, bright and dark, bright. So ini ialah diffraction pattern. Okay, so it proved that electron as a particle do have a wave behavior.
Crosswise, okay. They're bright in the middle, then dark, then bright, then dark. They're behaving like waves. So hang on, what is it now? Is an electron a particle or is an electron a wave? And what you might know of quantum physics is that we have the concept of wave-particle duality. And this experiment can only be...
So, dia kata tadi wave-particle duality. So, it proved that Davidson and Gemma buat eksperimen yang electron as a particle do have a wave property sebab dia shows a diffraction pattern. Right? So, bila dia naikkan dia punya voltage, dia nampak pattern yang lagi rapat. Okay, so that is the first part in you punya 10.2 electron diffraction. Okay, for example, soalan minta you lukis untuk Davidson and Gemma, you can draw this kind of setup. Alright, so that's for the first one, and I will explain to you for the electron microscope.